Though you never watch the videos, so I'm not uploading the videos because you never watch them. A concave mirror's focal length is 9.5 centimeters. A 3 centimeter tall pin appears to be 15.5 centimeters in front of the mirror. How far from the mirror is the pin? How tall is the pin's image in problem 306? Uh, this problem has well, it's the tail is back. Wait, I need to. Okay, so take a look. In this problem, it says we need to highlight the givens. Okay. So the first part that we care about is the kind of mirror that we have. As you can see, we have a concave mirror, okay? That is going to be the first given. Wait, this is not updating. Okay, yeah. So we're talking that this is about a concave mirror. That is the first given in this problem. They are giving us the focal length, which is 9.5 centimeters. They are telling me that the object is a pin, okay? And this pin is 3 centimeters tall, okay? So we're talking about the size of the pin. Now, it says that the pin is 15.5 centimeters in front of the mirror, and then they're asking you about what distance or how far from the mirror is the pin, but this question is incomplete. This is the pin's image, okay? So they're asking us how far from the mirror is the pin's image, and then how tall is the pin's image in the problem 306. So we are looking for how far is the image. We're talking about the distance of the image. Okay, so we start writing the givens. The first given is the type of mirror that we have. We have a concave mirror. The second given is the focal length. Concave mirrors have positive focal length. Okay, remember? The focal length for concave mirror is positive, but for convex mirror is negative. A 3 centimeters tall pin, okay, they're telling me about the size of the object. So the object, we know that it is a pin, and it has a size or is 3 centimeters tall, okay? And then it says that the object, that pin, is located at 15.5 centimeters from the mirror. Then they're asking me how far is the image, which means I'm looking for Q. How far is the image? And how tall is the pin's image? How tall is the pin's image? Here we're talking about the size of the image, okay? So in this case, the image size is going to be unknown. And the image size is known as H apostrophe, like that. So we are looking for the H apostrophe. Now, in the first part, what we have to do is we know that we had to use the equations. So we're going to be using the mirror equation. In the first step, we're going to be using the mirror equation to find Q. So we say that 1 over Q is equal to 1 over F minus 1 over P. You must substitute by the givens. And you say 1 over Q is equal to 1 over 9.5 minus 1 over 15.5. How much is this? Give me the answer as a fraction, please.
$24 over 589.
Over 500?
89.
89. Okay, these are centimeters. And then we apply the reciprocal function. So in the end, Q is going to be equal to 589 divided by 24 centimeters, and this in the end is equal to how much?
24.54.
Okay, so the Q, the image is positive, okay? Because it's positive means that it will be appear in front of the mirror. That's what the positive means. In the next step, what we have is, even if the problem is not asking you to find the magnification, we need the magnification because to get the pin's image height, we need to know the magnification, okay? So magnification is going to be the second problem, the second step. M is equal to negative Q divided by P. We substitute by the givens and we have how much is the magnitude?
1.6.
Negative 1 point, I got 58, but in the end, we can approximate to negative 1.6. About the magnification, we can say the negative indicates what type of image, virtual or real.
Real.
Real image. Real image means that we can see it, okay? That it will appear to us to be like a real something, okay? But it's just a reflection, okay? The other negative means that the image is going to be upright or upside down. Upright or inverted.
Inverted.
Sorry, yes, it is inverted. And the last part, which is 1.6, is a number that is greater than 1. So the image is going to be enlarged or is going to be reduced.
Enlarged.
Image is enlarged. Now, in the last part, okay, we already have the Q, okay, we already have the Q. We already have Q, and we need to find the image size, okay? To find the image size, we have an equation that I gave you. It will be the third step, okay? The image size, which is H prime, or H apostrophe, whatever you want to call it. H apostrophe is equal to magnification times the object's height. So this will be negative 1.6 times the object's height, that is 3 centimeters, and the image height is going to be negative 4.8 centimeters. The negative in this, sorry, you don't see it. The negative in this answer means that the image, as we said before, is upside down. That's what the negative means, okay? Now, we already answered the two questions, but remember, how am I? I always demand you to sketch all the ray diagrams. So, the next step will be draw the ray diagram. Even if the problem doesn't say it, you have to do it. So, to sketch the ray diagram, first we need the principal axis. That is just a horizontal line. Now I will sketch my concave mirror. I hope it looks nice. No, espera, wait. Oh, lo bonito que lo tenía. Yeah, I like this one better. Okay, so what I'm gonna do in the first place is I'm gonna write all the information that I need for the sketch, okay? Because remember, we need to choose the scale. To know the scale, we need to compare all the numbers that we have. So we have that the object size is 3 centimeters. We know that the image size is negative 4.8 centimeters, okay? We know that P is equal to 15.5 centimeters. We know that Q is equal to 24.54 centimeters. We know that F is equal to 9.5 centimeters. We don't know what the center of or radius of curvature is, but we can get it. You say C is equal to twice the focal, and this is 2 times 9.5 centimeters, and this gives you 19 centimeters in the end. Now, what happened with this? Okay, with all these givens, if I had to get like the greatest common factor, it's very difficult because I have decimal numbers, okay? So that makes it a little bit more complex to work with. Now, thinking on the size of my, well, of your notebook actually, and what I did in the end, I was comparing, okay? I was comparing. For example, if you divide by 5, the numbers are going to be too little. For example, 3 divided by 5, 0.6. Measuring 0.6 in your notebook is just too tiny, okay? So I was working with these common numbers, and in the end I decided by 2, dividing by 2. Perfect. Yes, I divided by 2. I choose to divide by 2 because this number here is too large, okay? 24 is just too large if I use the scale 1 to 1. So I divide each number by 2, which means that my scale in the end is 2 over 1. In the end, this gives me 1.5 centimeters. This gives me 2.4 centimeters. This gives me 7.75 centimeters. This gives me 12.27 centimeters, and here this gives me 4.75 centimeters, and this gives me 9.5 centimeters. These are the centimeters or the boxes that I can use. Okay, I'm gonna put in there. So I will start with the point P, Q, F, and C, which are the most important points in the ray diagram. So I'm going to start with these ones. Okay. So my point P will be located 7.75 centimeters in front of the mirror. So I will start counting. This is 1, 2, 3, 4, 5, 6, 7, 8. So my point P is going to be located 7.75. 7.75 is a decimal number that is between 7 and 8, but is closer to 8 than to 7, okay? So more or less, my point P is going to be here. That will be my point P. Between 7 and 8, closer to 8. Okay, because if I round it, it's going to be closer to 8 than to 7. Now my point Q is really not necessary that you put it, but I put it. Okay, your point Q is located 12.27. So I will continue counting. This is 10, 11, this is 12, and this is 13. So my point Q is 12.27. That is closer to 12 than to 13. So my point Q is going to be more or less here. Okay? That's my point Q. Now, a very important point is the focal. The focal is 4.75. Remember that we are working with the scale. it is located 4.75, which means that it's going to be between 4 and 5, closer to the 5. So my point F is going to be more or less over there. And then the point C, that is important that you put it in the sketch, is 9.5. 9.5 is between 9 and 10, right in the middle, okay? Right in the middle. So more or less here will be the point C. Now, remember that we place the object over the point P, okay? Remember, the object comes here. So my object is a pin, okay? My object is a pin. So I'm going to draw a pin. What size will my object have? Take a look. My object, which is a pin, has a height of 3 centimeters. By using the scale, dividing it by 2, the size of my pin is going to be 1.5 squares or boxes, okay? So my pin will be located here. Okay, so as you can see, it measures, this is 1, and here more or less is 1.5, okay? So my pin measures 1.5 tall, okay? That's the dimension that in the vertical axis. Now, I'm going to take that table and I will see what configuration I need to use. Remember that for concave mirrors, this is the table that we need to use. Okay, let's see what configuration matches. What configuration matches the array diagram that we have. What configuration matches the array diagram that we have. Take a look where the object is located. The object is located between F and C. What configuration corresponds to this situation?
4.
Configuration 4, that is correct. So let's see. We're gonna focus on the configuration 4 only, okay? Wait a second, I'm gonna bring it. It's because all that table is very big, so I cannot have it in the whiteboard. So I'm gonna use this configuration only, okay, as a reference for the sketch. And we're going to follow the rays, okay? So take a look, the first ray comes from the top of my object, passing through the focal point, I touch the mirror, and then I go back straight horizontally. So that is what I'm going to do right now. That's better. Okay, sorry. So let's see. My first ray comes from the top of the object. I do it in... Okay, the top of my object, remember, is going to be the center point. Like that. And my ray comes from there, passing through the focal point until I touch the mirror. That's my first ray. Okay, once I touch the mirror, I come back horizontally. More or less like that. Okay, remember to indicate that this is your first ray. Like that. Now, these arrows represent how the light rate is working. Okay, first it's been doing the reflection against the mirror, and then the mirror makes the projection of the reflection in this direction. Okay, that's what it means. Now the second ray comes straight horizontal from the top of the object, touching the mirror, and then coming back, passing through the focal point. So from the top of my object, horizontally, I touch the mirror. This is the ray number 2. Okay, and then the ray is reflected, passing through the focal point. Okay, like that. And then the third ray comes from the top of my object, passing through the radius of curvature. Take a look. From the top of my object, passing through the point C. So I will do the same. Okay. Now the point where when the three rays intersect is more or less here. Okay. That's where the three lines intersect. And as you can see, is almost in the same position that we predicted initially. Initially, we predicted that this was going to be the Q, right? And as you can see, even though it's not perfect, it's very close. When it's very close, we say that it's accurate. Now, according to the magnification, remember we said it's going to be a real image, it's going to be inverted, and it's going to be enlarged. So my image here is going to be inverted. So I'm going to draw it upside down. Well, more or less. Now, after we do this, we can confirm if what we got is correct, okay? Take a look at the size of the image. The image size, which is H apostrophe, here it measures 2 point, almost 2.5 squares, okay? Remember that we use a scale that is 2. So we multiply what we got by 2 to have the real H image height, and we obtain 5 centimeters. This is the image, okay? To compare if we have it right, remember the image is upside down, so it's going to be negative. Now, to compare if we have it correct, we're going to compare it against the image size that we got with the formulas. According to the formulas, the image size is 4.8 centimeters. The image that we obtained in the sketch is 5 centimeters, even though it's not exactly 4.8, we say that it is accurate. And with this, we confirm that what we did is going to be correct. So as a review, remember to use all formulas. Remember that concave mirrors have positive focal length, convex mirror have negative focal length, and remember to apply the formulas, mirror, magnification, in the case that the problem asks you for the image size or the object size. You can use isolations from magnification, okay? And then when you sketch the drawing, when you make the drawing, you will see the first ray passes always to the focal point and then returns horizontally. The second ray goes horizontally and then comes back through the focal point, and the third ray passes only through the radius